Hey Opties! Today we're learning about how to solve quadratics with square roots. So right off the bat we have a point to ponder that the square root of anything squared is that same anything. So for example, if we have the square root of x squared, it's just x because it's a square root. So to keep that in mind, that's the reason why we can solve by square roots like we do, and we can simplify square roots. Step 1 to simplify square roots is to find all the perfect squares of the radicand, which is just the numbers or variables, the stuff inside of the radical or the square root. Step 2 is to rewrite the radicand as a product of all perfect squares and whatever is left over. So we're just going to, whatever we found to be the perfect squares, we're going to rewrite it as a product of those. And that is because it makes it a lot easier for us to visualize what will come out of the square root, which is the step 3, to take all of those perfect squares out of the square root, because those are the bases that have simplified to just the base, because the square root of something squared is that something. And step 4 is just to multiply everything that's left over. So whatever has come out front or out of the square root now gets multiplied together, and everything inside the square root gets multiplied together. So here is an example. We have 3ab times the square root of 24a to the 5th, b to the 2nd, c cubed. I said b to the 2nd, you could say b squared, of course. So we're gonna find all of the perfect squares. So let's take 24 and let's write it with all of its perfect squares. So one way to do that is to make it a factor tree. So 24 could be 2 and 12, and 2's prime, so I'll circle it. Then 12 could be broken into 3 and 4, and 3's prime, and then 4 is a perfect square. So if you already noticed that, you wouldn't have to continue your factor tree, but you could. Let's go ahead and do it. We'll do 2 and 2, and those are prime. So we can write 24 as 2 times 2 times 2 times 3, which if we're writing as all the perfect squares, that's going to be 2 squared times 2 times 3. And that's what we're going to replace underneath the radical. So what if we had a to the 5th? That's going to be a squared times a squared times a, because you add your exponents to make up the exponent. So it's 1, 2, 3, 4, 5 a's. For b squared, that's just b squared still, and then c cubed could be c squared times c. So now let's replace our radicand with all of this we just found. And we'll keep our outside piece, 3ab. So now we have the square root of 2 squared times 2 times 3 times a squared times a squared times a times b squared times c. And yes, I know it's long, but I want to show you how it works with different exponents for your variables and for a number that's got some perfect squares in there. So now we want to take out all our perfect squares. So we've got a 3, and we have our 2 squared comes out as just a 2, because the square root of 2 squared is just 2. And then we have our a, and 2 of those come out, so 2 more a's. And then for our b, we have 1 b that comes out, but we already had one, so 2 b's there. And then 1 c comes out. And then we have a square root of 2 times 3 times a times c. So our final step is to multiply all these together. So 2 times 3 is 6, and then we have 3 a's, so it's a cubed, 2 b's, so it's b squared, and then our c, and the square root of 6ac. And that's our final simplified radical. You will not have to actually deal with the variables for right now, but that's just a reminder of how to work with that. You'll just have to do the numbers. So be comfortable with using factor trees and finding the perfect squares in numbers. When solving with square roots, it's going to always be an equation that is ax squared plus c. Of course, it would say maybe equals y or equals some other number. but it will not have any x term, and because of that, we are able to solve using square roots. So the first step is to isolate the ax squared term. Then we want to divide both sides by a, take the square root of both sides for step 3, and step 4 is to make sure to write our answer as plus or minus whatever we just had from taking the square root. So plus or minus that square root. Very important step, and something that is easily forgotten. So we have 2 examples. Notice there is no x term, it's just an ax squared term and a c term. If there was an x term, then we would try to factor that. So let's isolate our x squared term, or ax squared. Our a is 1 here, but let's go ahead and get that by itself by adding 2 to both sides. Then x squared is equal to 72, and we need to take the square root of both sides. So x is going to be plus or minus the square root of 72. Now, we're not done because we have to simplify this square root. So let's take 72 and do a factor tree. So it could be 2 and 36. And then 36 is a perfect square. It's 6 and 6. And if you wanted to keep going, you could go forever and ever until you get to primes, which is be a 2 and a 3 and a 2 and a 3. But what you want to take out of your square root are all the perfect squares. So you already see that you have a perfect square, so there's really no need to go any further. So x is going to be equal to plus or minus whatever the square root of 72 simplifies to. So let's just make sure we get it over here and do it correctly and don't miss a step. So we can rewrite 72 as 6 squared times 2, which is the same thing as the square root of 6 squared times the square root of 2. If you want to think about it this way, it might make a little bit more sense as to why this just becomes a 6, okay? And then we have our square root of 2 left over. So this is the same thing as the square root of 72, and of course we have it as plus or minus. So x is equal to plus or minus 6 square roots of 2, and that's it for our solutions. Let's do our second one. We want to isolate our ax squared term, so we add 2 to both sides. 2x squared is equal to 16. We'll divide both sides by 2. And x squared is equal to 8. Now we have to take the square root of both sides. And x is equal to plus or minus the square root of 8. So let's simplify this square root. 8 is 2 and 4. And we know 4 is a perfect square. Since there's not much left, I'll go ahead and do the rest of the factor tree for us to just see it. But since 8 is 2 times 2 times 2, we can rewrite the square root of 8 as the square root of 2 squared times 2, and that's going to be 2 square roots of 2 because this 2 squared simplified to just 2. So finally we have x is equal to plus or minus 2 square roots of 2, and that's it. All right, Opties, that's it for solving quadratics with square roots. See you next time.